So to begin this section, we are looking at the fundamental identities for trigonometry. Okay, so this section for this test 20 is really just on 13.6. We're just focusing on these fundamental identities because they're very important, especially for those that plan on continuing into AP Calculus and Calculus. You will see these again. So an example of a trigonometric identity is cosine squared x plus sine squared x equals 1, as you can see here on the screen. Okay, and this identity comes straight from the Pythagorean theorem. If you want to know a little bit more about it, it is I mentioned a little bit more in the notes, but the idea is that these identities are going to help us simplify trigonometric expressions and then verify other identities. Okay, and it starts a building block for kind of our understanding. So a lot of time these identities come from the definitions of trig functions just in general, once you start getting used to them, you'll realize they kind of flow together a little bit. Okay, so we've got two different types of identities. On the notes, I put 3, just because the book had 3, but the cofunction identities aren't really used that much in this lesson. The reciprocal identities, we've got sine x is equal to 1 over cosecant x, cosine x is equal to 1 over secant x, and that should make sense because cosecant and secant are the reciprocals of cosine, so we're just switching those two in their positions. Okay, and you can see that over here. So cosecant x is equal to 1 over sine x, secant x is equal to 1 over cosine x. Tangent x is equal to either 1 over cotangent x or 1 sine x over cosine x, and cotangent x is 1 over tangent x or cosine x over sine x. And then a couple nice ones in the middle, sine x times cosecant x is equal to 1 because they are just reciprocals of each other. Cosine x times secant x is equal to 1, again, reciprocals of each other. Tangent x times cotangent x is equal to 1, again, reciprocals of each other. So if you see those two terms, any of those two terms being paired together, you should know they should equal 1 if they're being multiplied. The other big one is Pythagorean identities, okay? So this kind of stems off a little bit of the top trigonometric identity that I mentioned before. We've got sine squared x plus cosine squared x is equal to 1, so a squared plus b squared is equal to 1. And then I just rearranged a couple of them. So it also means that cosine squared x is equal to 1 minus sine squared x, and sine squared x is equal to 1 minus cosine squared x. And then you've got 1 plus tangent squared x is equal to secant squared x, and on the flip side, secant squared x minus 1 is equal to tangent squared x. Then you've got 1 plus cotangent squared x is equal to cosecant squared x, and again, in a reversal of that, cosecant squared x minus 1 is equal to cotangent x squared x. Okay, so if you notice, we have two different colors here, pink and blue. Keep an eye on those colors because I'm going to try and show you using them when I'm using what identity as we simplify these expressions in the next example. So let's start off simple. We'll just look at number 2. Okay, we want to simplify cosine theta times cosecant theta. So first thing I'm going to do is use the reciprocal identity to change cosecant theta into 1 over sine theta. So I'm going to use pink equals cosine theta times 1 over sine theta. And then I'm going to simplify. So this is going to be equal to cosine theta over sine theta. Cosine theta over sine theta by the reciprocal identity is equal to cotangent theta. And that's my answer. Let's look at another one. For 6, we've got quantity secant of phi, that's what that little weird squiggly looks like, minus 1 times quantity secant of phi plus 1. So first thing I'm going to do to simplify is I'm going to FOIL. So I get secant squared of phi minus secant of phi plus secant of phi minus 1. Simplify. So we get secant squared of phi minus 1. This is we're going to use Pythagorean identities here and replace the secant squared of phi with 1 plus tangent squared of phi. So this will be equal to tangent squared of phi. Let's look at another one. For 10, we've got cosecant of x over sine x minus cotangent of x over tangent x. So first thing I'm going to do is I'm going to use reciprocal identity to change cosecant, cotangent, and tangent. So I get 1 over sine x over sine x minus cosine x over sine x over sine x over cosine x. Okay, so this will be equal to 1 over sine squared x minus cosine squared x over sine squared x. I need to get a common denominator to subtract these two fractions, and lo and behold, the common denominator is sine squared x. So I get 1 minus cosine squared x over sine squared x. By Pythagorean identity, the numerator is just equal to sine squared x over sine squared x. So this is equal to 1. Let's look at another one. In 24, we're given secant squared alpha minus 1 over secant alpha plus 1 plus 1. Now, before you start plugging in a whole bunch of trig identities, start with algebra identities first, okay? So we've got secant squared alpha minus 1 in the numerator. We can factor that, right, because it's a perfect square here. So we've got secant alpha minus 1 times secant alpha plus 1 over secant alpha plus 1 plus 1. My secant alphas will cross out, and I get secant alpha minus 1 plus 1, which is just secant of alpha. So there's a pattern. If you notice, all of my answers in 2 through 6, 10, and 24, I ended up with one term at the end of it. On your homework, you should end up with one term. If you end up with more than one, you did something wrong, okay? Or you haven't simplified enough. Now let's look at 26. 26, 20, 30, or in your case on your homework, 25, 27, and 29 have a bit different directions. They give you cosecant x and cosine x, and what it says in the instructions is that they want you to write the first term in terms of the second term. So we want to write cosecant x in terms of cosine x for 26. So first thing I'm going to do is I'm just going to copy down cosecant x, and I'm going to think, okay, well, what can I use to make this simple? Well, first, a big step usually that's pretty simple is to convert to sines and cosines. So I'm going to use reciprocal identity to change this to 1 over sine x. Now here's where we hit a snag, because we don't have an identity that it only solves for sine x, but we do have an identity that says that sine squared x is equal to 1 minus cosine squared x, right? So what we can do is take the square root of each side, and so we get sine x is equal to plus or minus square root 1 minus cosine squared x. And so we did just solve for sine x. So we're going to plug that in for sine x over here for cosecant. So we get plus or minus square root 1 minus cosine squared x. This is the one instance I will let you keep this radical in the denominator just because it's a plus or minus and it's a nasty number underneath the radical. So we'll leave it as is. And so this is our answer because we got cosecant in terms of cosine. Let's look at another one. In 30, we have tangent of alpha times secant alpha in terms of cosine alpha. So first thing I'm going to do again is write down my first term so I know what I'm supposed to start off with. And then I'm going to use the reciprocal identity to get everything into sines and cosines. So I have sine alpha over cosine alpha times 1 over cosine alpha. Simplify, we get sine of alpha over cosine squared alpha. Okay, and if you notice the squared is next to the s on that, that means quantity squared. So it's a cosine times a cosine. So we have the denominator in terms of cosine, but we don't have the numerator in terms of cosine. But we just did it above that sine is equal to plus or minus square root 1 minus cosine squared of the same angle. So we copy that in. And we've rewritten tangent alpha, secant alpha in terms of cosine. So we're done. Lastly, let's look at 42 and 46. Okay, so in 42, they give us the expression sine of phi plus cosine of phi times cotangent of phi. So first thing I'm going to do is I'm going to use a reciprocal identity to change cotangent of phi. And I'm going to change it into terms of sines and cosines, just because I think that's going to be the most beneficial in helping me solve my, simplify my expression. Okay, so we're going to simplify now that we've changed it to cosine theta over cosine phi over sine phi. So we've got sine of phi plus cosine squared of phi over sine of phi. In order to add a fraction to a whole number, we need to get a common denominator, which is sine of phi. So we're going to multiply. We get sine squared of phi plus cosine squared of phi all over sine of phi. Using Pythagorean, this is equal to 1 over sine of phi. We are not done though. We cannot leave this as a fraction. So we're going to simplify further using reciprocal, and we get cosecant of phi. Now let's look at 46. We have sine of alpha over 1 plus cosine alpha plus 1 plus cosine alpha over sine of alpha. So first thing I'm going to do is get a common denominator because I'm already in sines and cosines here, so I can't simplify that way first. So I'm just going to get a common denominator. I get sine squared alpha plus quantity 1 plus cosine alpha squared all over sine of alpha times 1 plus cosine alpha. Okay. In order to really simplify, I need to FOIL that quantity squared in the numerator. So I get sine squared alpha plus 1 plus 2 cosine alpha plus cosine squared alpha all over sine of alpha times 1 plus cosine of alpha. From here, I need to combine like terms. So I'm going to move the cosine squared next to the sine squared, and then recopy everything else because that hasn't changed. And if you notice, this right here, sine squared alpha plus cosine squared alpha, is a Pythagorean identity, and it's equal to 1. So I'm going to combine my 1's in the numerator, so I get 2 plus 2 cosine alpha over sine of alpha times 1 plus cosine alpha. I can factor out a 2 from the numerator, so I get 1 plus cosine alpha over sine alpha times 1 plus cosine alpha. My 1 plus cosine alphas cancel out, and I'm left with 2 over sine of alpha. We cannot leave this as is because we can simplify it further. So I'm going to use a reciprocal identity to change this to 2 cosecant alpha. And that'll be my answer. And that's the lesson, okay? So classwork due May 1st for F block and May 2nd for C block is page 639 to 640, numbers 1 through 29 odd, and 39 to 47 odd. For those that are having trouble keeping track of their calendars, test 20 will be May 8th. That's a Monday. It'll be 45 minutes, so it'll be a quick in and out, okay?